Recording on. Great. Okay, so uh, last session was about a very difficult and complicated topic like subnetting. So I'm going to take a few more examples based on subnetting, right? Because topic is a bit complex, so uh, I need like more examples. But before that, before I just jump to this trouble subnetting examples, maybe a couple of more examples. Before that, let me start with another very important point here, and then I will be back to this subnetting again. And another concept, just a high level overview. So I want to give you about the gateway or default gateway. So like what is gateway? What do exactly gateway? What does gateway do in fact in network? Or what is the role of gateway? So far we have discussed like that IPs should be from the same network or same subnet, because if IP addresses assigned to end devices are not from the same subnet or same network, so they will not communicate with each other. So far we have learned all this. I mean, like if there are two, three, four computers, so IP that we assign to end host devices should be from the either same network, or if we have done subnetting, so IPs must be from same subnet, from the same subnet. Otherwise, no, like computers do not communicate. So, and even in case if there is no subnetting, but if IP address assigned to one computer is 10.0.0.1, another machine 10.0.0.2, third machine, third computer 11.0.0.3, and then 11.0.0.4. So basically, there are now two networks, in fact. A network of two host devices, they will communicate, and another network of two host devices, they will also communicate with each other. And there is no concept of gateway or default gateway kind of thing. But in case if like intensely we have done all this, we have done network segregation, there are different networks, and now we want that both networks should communicate with each other. So if I take any example, like let's say, let me start with very basic, simple example, that if a organization or company has two locations, different locations, two networks, two different locations, maybe location A, US East region, for example, anywhere in US East region, and location B is in US West region, in US West region. So in US East region, in location A, let's say there are like end host devices, and here there is a switch. And in location B again, a very large enterprise network, maybe 100, 200, or 500 devices, host devices, they all connected to the switch. And here, like location A, IP address, let's say IP address assigned here is 10.0.0.1, 10.0.0.2, 10.0.0.3 private IP address, and here 10.0.0.4. Location B site IP address assigned here is 172.16.0.1, 172.16.0.2, 172.16.0.3, and 0.4. So Basically, there are now completely, there are two networks, one network here and another network here. Is there any request from someone? Okay, giving you record permission. Just wait. Yeah, given. Yeah, I have given record permission. Oh, yes, recorded starting. All right, so there are completely two different networks. There are two different locations. Now, like objective is to do like networking between these two networks, a type of wide area network. That is objective requirement that both networks should communicate with each other. Means network at location A and network at location B, they both should communicate. So if I'm sitting here on this computer 10001, so I should be able to communicate with this machine maybe in different location. So for that, of course, physical connectivity is required. I mean, like these two networks need to be connected with each other. Network at location A and network at location B. And if they both are 100 miles or 1,000 miles or kilometer away from each other, so how do we connect both networks? I mean, like if I have to connect both the switches, so for me, not possible at all, right? And even like networks can be in different continent, maybe one network in East Africa, another network West Africa, one network in like maybe America region, another one is in Asia. So not possible at all for any organization, for any company doing physical connectivity. And you understand like why this wouldn't be possible, because they are very far from each other. So not possible at all. We cannot do the physical connectivity. But with the help of service provider, that can be possible, right? So if we are ready to pay a service provider, the same service provider, telco or internet service provider, so we can ask the service provider to provide physical connectivity between these two different regions, no matter whether they are 1,000 miles away from each other or maybe 100 miles, right? Because already service providers have laid down optical fiber cable, right? Underground cable, or maybe in ocean, right? Submarine cable already is like going through everywhere in different countries, continents, right? So basically, we can ask the service provider to provide network cable on leash. One of the way like is a dedicated connection. So one method is dedicated connection, running point to point link, in fact, between these two locations, right? So service provider will facilitate physical connectivity. And the shortcut method is something like using internet as the transport, as we all are connected with each other, right? With the help of internet. So internet is another method. So basically, measure like there are two different ways to connect two different locations. One is like connecting both networks directly with a optical fiber cable, right? And this cable is not laid down by organization or company, no. Not even like a service provider is going to lay down cable at that time, no. Already cable has been laid down, right? Underground, underwater, already is there, right? We just take on the lease. We pay rent to those like medias and all that. And that's like the best way of connecting different networks, right? Dedicated connection. Dedicated connection is the best way to connect different networks, but expensive solution. We would have to pay a huge amount of money monthly basis, right? Or maybe per annum. Internet is another transport method, so we can use internet. But the point of discussion here is a bit different, right? Mainly, I'm not going to focus on like these two different common most methods, but there are two common most methods. There are basically plenty of ways to connect different sites, but these two are the common most method. Now, Let us assume like connectivity wise we are not bothered like how they both are going to be physically connected. Let's say we would ask like service provider to provide some lease line connection, or maybe like both locations are in the same city, maybe not very far from each other, right? But again, like even in the same city, but still we need like support from the internet service provider, because we cannot run cable like uh, in the middle of the city or like like any market or place. No, not at all possible, because overhead cable, yes, not possible. They all need to be underground cable, and so a lot of work required, in fact. So let us assume like somehow we manage to connect both networks no matter how far they both are like from each other. But that's not done, in fact, right? Simply if we just connect both switches with the cable, still they are not going to communicate. You understand? 10004 will not never communicate with 172.16.0.4. But it's not about the physical connectivity. Okay, like physical connectivity, we done that, right? Both switches are connected with each other with any cable. But since IP address is not from the same network or subnet, so they will not communicate, right? I hope this point is clear to all of you, that if like IPs are from different network or different subnets, so by default, no communication at all. So what is the way then? What was the way how like we can make this communication happen? So basically, for that, we need another network device, right? Switch is one device. Switch is what? A network device. Now we need another network device. Another network device. Two devices, basically, right? And this device is known as router. 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 Your home network router is also a router, basically, right? Your Wi-Fi router, or maybe broadband router, right? Cable modem plus router kind of thing. But these are a bit different, like enterprise routers, in fact, not meant to be like only for the home network or small office, home office network. No, they are meant to be used in enterprise networks. And again, like Cisco is the leading vendor. Cisco is the big name, big company, the vendor, right? Manufactures routers, switches, and a whole bunch of network devices. Apart from Cisco, a very big name is like Juniper, even Nortel. Like a lot of vendors are Nortel now has gone like in the during last recession period. In fact, this company, like the company was backbone of Canada, Nortel, Northern Telecommunication, but now has gone. Uh, like in major crisis like recession, in fact, like a decade before earlier. But these two are big names apart from Huawei and some other like brand, in fact. So they are different vendors, companies. They manufacture routers, switches, and other devices. So in enterprise network, mainly we use Cisco routers. So Cisco is leading vendor, a company name, basically US based company, a very big company, Cisco Networks. So router is again a network device, and router is a bit different than the switch, because switches are mainly used in like setting up or building a local area network, LAN network, right? A centralized device where like all end host devices connected. Router is different. Router is like for routing traffic between or across different networks. Or in simple word, you can understand router is a network device mainly used in like ensuring like communication to happen across different networks, routing traffic between or among different networks is a network device, right? So mainly for the WAN network, wide area network router. And these two routers, so one interface of the router is connected with the switch, here again with the switch, And then these two routers, if I name it R1 and here R2, so these two routers, R1 and R2, need to be connected with each other. Now here, like your service provider is playing important role. With the help of service provider, basically they both will be connected. Obviously, we are not going to connect them directly. We are not like running this cable. No, it's service provider job. But configuring both routers is the job of network engineer, right? Network engineer that a company hires. So your profile would be configuring these two routers, not running the cable. No, that's some service provider will take care of. Service provider will charge for that. So you don't have to worry with like running these cable, connecting both routers all together. No, you'll have to configure both routers locally at your end. Physical connectivity, no need to bother with the physical connectivity. Okay. Now, the router again here IP address from the same range. Like here, if I take the example of R1, so interface, the internal interface that connects with the local switch, and this is another interface, right? Runs like here, like WAN site. So basically, router means minimum two interfaces. Two interfaces are two LAN card or Ethernet card. One for external connectivity, WAN site, WAN port, and another one is what? LAN port, local area network port. Both ports need to be assigned IP address, right? So today, but I'm not going to talk about the WAN port. Mainly, I want to focus at LAN port, local area network port. Now, this LAN port, internal port, should have IP address assigned from the same network, right? Same network here. Like the first machine has 10.0.0.1, the second one is 10.0.0.2, third one 10.0.0.3, 10.0.0.4. So you can assign any IP address, but from the same network address range. So this LAN port can have IP address 10.0.0 or any address, let's say 200, no problem, but should be from the same network address. So it is another end host device, right? IP address 10.0.0.200, this address. And after assigning IP address to the router, to the network device, now computers, LAN site computers, these computers, right, should have gateway IP configured, or default gateway or IP address, default gateway, because here router is what? Gateway, gateway. And what is gateway address here? 10.0.0.200. So this 10.0.0.200 should be configured as a IP configuration, a part of IP configuration on all end host devices. And why do we do that? Right? There is a gateway, router is a gateway here. Gateway IP is 10.0.0.200, and this IP address should be known to all end host devices. Why? Because if packet need to be routed outside this network, means if computer 10.0.0.1 wants to communicate with 172.16.0.1, right? Both are in different network. So gateway is mediated here, entry and exit point of the network. So computer will send packet to the gateway, to the router, and then router will do rest of the things. So quickly, if I take here or take you to this packet tracer just to show you, and then I will just move to like this subnetting again. So as I mentioned, like if there are two networks here, if you have one, two, just take two computers only. I don't want to make things very complex. Let's keep it simple. So there are two machines here, is location A and location B. So LAN network is something like very straightforward. Just take a cable, click here again, take a cable, and done. And here again, another network and done. Okay, so this is my network A, network A. Network A means like any location, of course. So network A, right? And I'm going to use this network address 10.0.0.0/8, means like IP address will be provided from the same range. And here I am going to take network B, another network, and here 172.16.0.0/16. This IP address will be assigned from the same range. Now, if I just assign IP address to this computer, let's say, and before that, let me take this device also router so that you can understand. So I took this device, and it's very much like a network device connected here, and if not will come up, then I will change the cable, and then again I will connect these two routers also together. It's a WAN connection, and what cable I took here because it's not showing. Okay, so let me just 1 minute. So I believe I will like explain all the commands, like what command we run here to configure devices later on, maybe tomorrow. But for now, just quickly, I want to bring up both interfaces. So sorry, interfaces are not up. So I want to just bring up the interface. It's not relevant, like so. I will explain later on. Just I wanted to show you like the interface is like turning up green. So that's it. Nothing else. The rest configuration I will do later on. I will start from the beginning, like how to start doing configuration. So it's not very difficult, but yes, like practice, yes, practice required. So for now, not required. So it's more than okay. So probably both interfaces would be now up. Okay. So now you can see like both interfaces turning up green. So now like here one network location A and the network location B, and the symbol here you see here is like a router. It's a router symbol, the WAN device. One interface like is LAN, another one is WAN interface. So IP address, like this interface should have IP address router, right? So let's say you want to assign IP 10.0.0.1 IP. Yes, you can assign, and here 10.0.0.2. That's okay. And this interface should also have IP address assigned. Any IP address you can assign. Let's say 50 I assigned, no problem. And same here, like if computer has like 0.1, this machine is 172.16.0.2. So this interface should have IP address, any IP address, let's say this one, from the same range. So now, let me see, but can we show like interfaces as well if there is any option here? View port. Okay. So this one should be, just a minute. if I get the option to this, draw line, rectangle, ellipse, freeze, use, where is that? Resize, delete. So maybe customize. What is this? No, so not given here. I was basically looking for like the interface name. So I'm not saying here. So basically, this is your, like this interface is F0/0 interface. So if I take mouse, then probably it will show here. Yeah. So gig 0/0. All right. So if I take my mouse here, then it's showing here like the interface name, like 0/0 or 0/1. Okay. I'll explain that later on. Forget that. Not required here. So now there are two different networks, network A and network B. Put this my mobile phone in silent mode. So creating new business. Okay, so there are two networks, network A and network B, right? Maybe this one is different site, different location. This one is in different site, different locations. Router is used here to connect both networks. Now, this router is basically known as gateway device. Gateway. So IP address is 10.0.0.50. Now these two computers should have default gateway configured, right? And when this gateway, this router would be required. So now let us assume that I want to communicate with this PC 172.16.0.1. My IP address is 10.0.0.1, right? So if I'm sitting here and I want to ping, I want to send some packet to this machine. So what will happen? The TCP/IP protocol stack will first identify that whether destination machine like 172.16.0.1 is from the same network or not. And you understand 172.16 even is like from the class B, network ID is also different, not from the same network. So immediately TCP/IP will come to know that destination machine is not from my same network. So what need to be done then? How to reach to different network? So for that, there has to be a gateway device. Already there is a gateway, but the gateway should be known. So even if there is a gateway, even if there is a gateway, but we don't tell computers about the gateway, so this is useless then, right? They would not be knowing like how to come out of like this network. I mean, like gateway is something like, let's say there is a very huge building, apartment building, a very large maybe premises, right? Campus, college, or university, and there are different rooms here, or maybe different buildings in the same premises, right? So let's say from one room to another room, let's say room number one to room number two, you want to move, like you want to get into room number two. So no matter like where the main gate of the building is, right? Just give me 1 minute, please. Maybe like some urgent calls. Just. Sorry, I'm back. All right. So now if you want to move like from one room to another room, but in the same building, in the same premises, so like even if you don't know like where is the main gate of this large like premises or building or campus, no problem, no problem whatsoever. You don't have to access or you don't have to reach to the main gate, in fact. But now, if let's say there are two like different locations, premises, and from here, let's say from this room number one, you want to get into room number two of another premises, right? A very big campus network, in fact, a campus. So definitely now, you should be knowing like where is the main gate, like how you can come out of this premises and the main gate of another building or premises also, because now, yes, this main gate, like the entry and exit point should be known to you. So even if like this campus or premises has a main gate, but if you don't have any idea, you don't have any knowledge, so how to reach there, in which direction the main gate is, so obviously like you won't be able to come out of this, and you cannot get into different area or premises. Same here, even if here like there's one network A, network B, maybe network A like has 500 computers, network B has 1000 computers. So 500 computers, they can freely talk to each other, provided they all should be using IP address from the same network or same subnet. So if they all have been assigned IP address from the same network, same subnet, so yes, like they can freely talk to each other, no problem, no problem at all. Now, if a host device of network A wants to communicate with host device of network B, and network B is it different region, different location, different IP. Now, gateway first, like gateway is required, and even they should be knowing gateway address or default gateway. So even if like we don't like let's say if I assign this machine IP address here 10.0.0.1, 10.0.0.1, let me assign one IP address here. So if I assign IP address 10.0.0.1 and mask here, right? IP address and subnet mask. There is one question, do both machine and gateway connected has to be same network? Yes, yes, very valid question. Internal interface of the gateway and end host devices, they all need to be from same network address or subnet address. So even if I assign IP address to the gateway, internal interface, I mean this interface, IP address from different network, this one, let's say the IP address here is something like 192.168.0.1. So this is invalid configuration, will not work then, right? Because if the computer IP address and internal interface of the gateway, if not from the same network, then again there is a problem, because this machine then won't be able to connect or reach to the gateway. So gateway internal interface IP and end host device IPs, yes, very much they all should be from same network. So that's very valid question. They all should be from the same network. So you can assign any IP address here, but make sure that IP address is from the same network or subnet, because I have explained a bit about subnet also, so you understand. If subnetting has been done, so they all should be using IP addresses from same network or same subnet, mandatory, right? Not optional even. And in most of the operating systems, so we generally get error message if the IP address and the gateway address both not from the same network. So if you look at the IP configuration here on this machine, so IP address 10.0.0.1, default subnet mask 255.0.0.1. And I have not assigned gateway here, and even I don't see like option here, like in this virtualized environment. It's a virtual environment. So if I go to this probably where do we get this option? So let's see, fast Ethernet. So because here I can see like IP address and this what you call it. Even if I go to this IP configuration page, then like this is the main page. So it looks similar to like that we see on our laptop or desktop. So better like if I just go here. So now I'm not going to this config page like straight away to desktop and IP configuration. So it is very similar to like that we see in physical computers. So here you can see IP address is there, subnet mask is there, DNS server just for now you can ignore this. Gateway is like blank or there is no gateway address. So is there any problem? No problem. Even if like I just take this machine and here again now I'm going straight away to this machine 10002. There is gateway, improper gateway, not gateway, or any gateway here, invalid gateway. Even in case if we don't get any error message, no error message, in fact, in this simulator, even like this is absurd, illegal, invalid, because IP address and gateway address should be from the same network. So even if there is no gateway address, no problem, right? Now the question here is, will they both communicate with each other without gateway? What do you think? Like yes or no? Without gateway, I'm not assigned gateway address. So you can answer in yes or no. The question is, without
Yes.
gateway, will they communicate?
Yes.
True. They will communicate, right? Because gateway address is required only if the source and destination both are not in the same network, then only, right? Even if you take the example of your personal laptop or desktop, you connected with the internet. So yes, gateway is required because at your home, maybe if you have Wi-Fi router, broadband router, not even this is not the cable, you have connected without wire, wireless connectivity. But this Wi-Fi router would definitely have two IPs, right? One IP, internal interface IP, internal IP address, and your laptop IP address, both same network. So generally the first address you find like your gateway address like 192.168.1.1 most probably, and your laptop is assigned automatically IP address from the same range, right? So maybe 192.168.1.2 or 1.3, or maybe your mobile phone, laptop, smart TV, different IPs, but from the same range. Now, another interface, external interface, because router means minimum two interfaces, two networks. Router means like always connect with two networks, two different networks, right? Minimum two networks. So another interface connected with the help of service provider connected with internet. And this cable can be your cable modem or optical fiber cable, copper cable, depends like what service provider you have in your locality, in your region, what type of media the service provider is providing at your home or office, depends, right? It varies from region to region, location to location, but most probably nowadays everywhere there is optical fiber cable or FTTH technology, fiber to home or something, everywhere nowadays. So because nowadays like I think the internet speed has gone up to 1 gigs even. So here in India also like 200 Mbps, 500 Mbps internet is very popular. And in India is also very cheap, in fact, the very cheap internet connectivity. So we enjoy up to 500 Mbps internet, unlimited, unmetered bandwidth generally. And it's unbelievable, but it's the fact that hardly if I convert in dollars, so maybe 10 USD per month, not more than that, 10 or 15 USD. So broadband internet connection is very cheap here. And uh, because of like users and population and other reasons. Anyway, so the internet router now, your home router has basically two interfaces. One interface is your LAN interface, right? Either whether you have connected with wire or not, no matter. But yes, router means minimum two interfaces. And your computer definitely would have gateway address, right? You can check your internet connection. You will find gateway address configured there automatically. If your router address is 0.1, then you will find 0.1 as the gateway. If your router address is 1.1, then you will find 1.1 as the gateway. And another interface is external interface that goes to internet, and this interface IP address is generally provided by your local internet service provider. So we don't care like what IP address has been provided and generally provided automatically. So even home router, yes, there are two interfaces and it's doing routing because what you are doing, you is your laptop or personal machine, right? But with this Wi-Fi router, you are accessing different networks. Yahoo is different network, Hotmail is different networks, Cisco is different network, Google is different network, YouTube different network, Facebook different network. Because internet is what? Network of networks. So you are communicating with different networks. Maybe Yahoo IP address is starting with 20. Maybe Google IP address is starting with 103 dot something. My machine IP is something different, right? So even though this Wi-Fi router, what it does, it also translate internal IP address, private IP address with the public IP address provided by internet service provider. So internet service provider or maybe your home router will do that, right? Will do the translation. But that's not my I want to explain here. What I want to explain that even in case if you have a single machine, a laptop, a desktop, but very much you are doing routing, right? Why? Because your Wi-Fi router, home router, broadband router is doing routing, facilitating communication to happen across different IP networks. Because Yahoo, Cisco, Facebook, Instagram, Twitter, they all are different networks. So we are doing routing. So without gateway wouldn't have been possible. Same here. So if here like on the LAN segment, there are 200 computers, they want to communicate with each other. Yes, gateway is not required at all. If there is wrong gateway address, no problem whatsoever. But from here to here, like different networks, so there should be gateway. Gateway should be properly configured. These two devices should also be properly configured. I will talk about that. Plus, host devices, they all should have gateway IP configured. And in this example, gateway IP is what? 10.0.0.50. So even if I don't configure gateway and if I try to communicate from this computer to this machine, 10.0.0.2, no problem. Yes, this proper response 10.0.0.1 is communicating with 10.0.0.2. But if I try to communicate with another machine in different network, even though like both routers are not properly configured, but let us assume they both are properly configured, still no reply at all. However, in this scenario, routers are not configured because I haven't started that topic, like configuring routers. I will be starting maybe tomorrow. But even if I assume like both routers are properly configured, it's still like the same result I would be expecting. Why? Because this computer doesn't have gateway. Gateway is there, but this computer should have gateway configured. And where do we do that? So we configure gateway here just below this gateway. So in this diagram, gateway is what? 50. So 50 should be gateway address. Very, very important. So I hope you all understand the concept of gateway as high level overview. So gateway means a router, a network device responsible for like routing traffic across different networks, right? This device facilitate communication among different networks. That's what your gateway is. So gateway is entry and exit point of a network. Entry and exit point of a network, right? So gateway is what? Entry and exit point of a network. And why gateway is not required? In case if we are doing internal communication, because we are not reaching out to this device then. If here, like in this network, there are 500 computers and they all want to talk to each other internally, yes, we don't have to like reach out to exit point. No, exit point means like the device, like from where packet will be routed across different network. Yes, would be required only if we would have to route traffic to different networks. So that's the concept of router. And in this diagram, these two interfaces should also have IP address assigned. Router means minimum two interfaces connected with minimum two networks, minimum two. There can be more than two. Now, this interface IP and this interface IP, yes, there should be IP address assigned to both the interfaces. And quickly, if I like just talk another important point here. Now, if I assign IP address, let's say 192.168.5.1, for example, and here again 192.168.5.2. So 192.168.5 means class C address, class C address. And in class C, if you remember, so there is maximum 254 hosts or IP addresses available. 254 IPs available in the network. 254, right? 254 IPs in single network. And here what I did, I assigned two IPs from this network. One IP assigned to this interface, one IP assigned to this interface. And remember, class C network total 254. I have utilized two IPs. What about remaining 252 IPs? Wasted, gone. Right? So in case of public IP, again a major issue. So can we do something in general? No. In general, we can't do anything because already we have used class C network. And remember, class C is the smallest network. In a single class C network, 254 valid IPs are hosts, valid IPs. Total 256 minus 2, first and last reserved. So still there are 254 IPs. Class B is big, very big, 65,534, and class A is much bigger. So even we have done our best. In fact, we have used class C address, but still we have wasted 254 IPs because here there is requirement of two IPs only. But subnetting, yes, subnetting can address this problem, because if a network, class C network, consisting 254 hosts, if divided into a small network, maybe we can find a very small network with only two valid IPs. Will that be possible? Yes. And if that is possible, then that means we have not wasted any IP address. What we have done, we have divided class C network into n number of small networks. And we have divided in such a way that a small network should have nearby approximately or maybe exactly two IPs only. And if I have used IP address of a subnet, one IP assigned to this interface, technically it is known as P2P interface. P2P stands for point to point. So would have been much more better. So even like subnetting, yes, is going to be beneficial here. We can do subnetting here also, because we understand, like whenever we talk about P2P link, P2P circuit means only two IPs. We need a network with two IPs only. But as there is no a network of two IPs only, networks, right? The only solution is subnetting that we discussed in the previous session. Subnetting is the only solution because network wise there are three classes that we can use. Class A, B, C. C is the smallest one, 254 hosts, no other network class. So maximum like possibility is what? Doing like segmenting, logical division of a network into small subnets. I'll talk about this also. So now let me quickly jump back to subnetting again. So I hope you understand like the concept of gateway in general. How like gateway is configured, how we configure routing, what are different commands, because a lot of things we do from CLI, command line interface. Even though it's command line, but it's not very difficult, right? Nothing is difficult than subnetting, believe me, in CCNA. So if you can understand subnetting, IP addressing, so you can understand anything. The other things are not as difficult or complex as your TCP/IP concept is. So you will understand, even though it's CLI command line, but commands are easily like help is provided. Step by step, I will show you how to configure these devices. So in real time, also you would be in a position to configure like network devices, routers, and other devices, no problem. So now I'm back to the same concept like subnetting. So because it was about your gateway concept or default gateway, rather I would say default gateway means the default like the device like which can be used as a default gateway means like if anywhere like let's say I don't know even the destination machine is, I don't know where to go, where to reach, but what I know like as a PC, I know that destination is not from my network. That's what I know only. What I know that destination is not from my network. Destination is maybe anywhere like different. So for that, if destination is not in the same network, destination is in any different network, so what I should do as an end host device, blindly I should forward the packet to my gateway, right? I don't care what, I don't know what would happen then after, right? My like responsibility is what? Sending packet to the gateway. That gateway take the packet. I don't know how to route the packet. I don't know where the destination is. I no have no idea, right? What I know, like I want to go out of this network. So you are my exit point. So take my request, take my packet, and do the needful. So this device will do the needful. Because maybe in the real environment, there can be another path, right? And the router to reach to the same network. So even this router, this device will perform path computation, whether I should route traffic this way or I should go this way. Which one is the best one, right? Which path I should prefer, why I should prefer. So this device will make some intelligent decision, not the end host device, no. End host device job is done. End host device job is what? To determine whether destination is from the same network or not. If the destination is not from the same network, then just sending packet to the gateway, done. End host device job is done. You don't have to do anything on the end host device. Rest of the configuration would be done on this device. Best path selection, routing traffic to different networks, right? A lot of configuration like would be required here. We'll understand those configuration later on. So it's something with the gateway. So I hope you all understand the gateway concept. And let me bring you to another very important discussion, like based on subnetting SL. So I'm again back to the subnetting. Okay. So here, like there are some questions designed to test your understanding IP addressing and subnetting. So now, let me minimize size a bit. Okay. So now you can see properly. So I'm reading the first question and be ready to give me the answer. Question number one. In the network shown in the diagram, how many computers could be in subnet B? So there are different networks here. Network A, I can see here. Network B is another network. And here, like in network B, I can see like here also there are two LAN networks. So one LAN network is this one, I believe, uh, bus slash 28. Here again, same slash 28. Okay, in the same network. Network A again slash 29 slash 27 here. And this symbol is a router symbol. Two IPs here I can see assigned like 73, 74 is something network address. So, but let's keep it simple. So question here is how many computers could be in subnet B? So first thing, like how we can find out the answer to this question means we have been asked to compute number of IPs in a subnet. But how we can do the computation? So for that, the help is given here is a network address, and this is the mask, in fact, subnet mask. Remember when we just done subnetting, so I created a chart or table, and table was like subnet address, the first address, and then range of IPs, and the last one broadcast address. Subnet address is like the first address, last address, broadcast address, and then range of IPs. So here, like the question here is about not straight away doing subnetting. Subnetting already done because you can see here like the mask /28. Because without subnetting, if you remember, so let me quickly recap those concepts as well. So if you remember, so in class EA, first octet represent network portion. So if I write down in binary, so binary representation would be this. In decimal, I can write down this, or in CIDR notation, I can write down /8. So there are three different ways to write down subnet mask, right? In binary representation, 8 ones and then 24 zeros. In decimal equivalent value, 255000. I can also use this notation, CIDR block, a CIDR notation, classless internet domain routing. Some people read it CIDR, right? And some people just CIDR, 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 one of the same thing. It's just the way of like notation. In fact, it's just like a way to define or represent network address. That's it. So /8 means 8 bits network portion. And yes, you can, if you look at the binary representation, so you understand 8 bits is network. So how many bits like host portion? So even I can straight away I can compute host bits. How? Because total number of bits is equal to 32. So if 8 bits network means if I subtract 8, so 24 bits. And even if you count number of zeros from here, 24 zeros. So in class A, 24 zeros means 24 bits, host bits. And how many hosts we find in class A? 2 raised to the power 24 minus 2. In class B, if you remember, so in class B, subnet mask is 8, 8, 8 zeros, 8 zeros, right? So in decimal is 255,255,00, or in CIDR block we can write down /16. So how many host bits in class B? So total 32, 16 network, then remaining 16 host bits. So how many hosts in class B? 2 raised to the power 16 minus 2. Minus 2. And why minus 2? Because first and last cannot be used. So now use the same logic and try to give me answer of this question, that how many computers means how many hosts or how many IPs you would find in this network address. If this is the network address, and mainly you need to focus at this /28, 28 network bits, in fact, remaining host bits, of course. So if /28 is the mask, then the question is how many computers could be in subnet B? Is it 6 computers? 12 means 6 IPs in that subnet, 12, 14, or 30. So now if further I minimize this so that you can side by side you can see. Okay, now you can see both. I will share this sheet also. So here is the network address, and question is how many hosts means how many IPs in that subnet. Already it's a subnet address. It's a small network, right? It's a small subnet address, and the first address is also written here. The reserved one, 192.168.10.48. Already subnetting, already done. One IP is assigned here 49, 50 IP assigned here 50, 51, 49. Some more IPs maybe. So we need to find out how many IPs in this network total. Already I can see 3 IPs already in use. Forget about this. 3 IPs already used, 49, 50, 51. But total, how many IPs? Like, is it 6, 12, 14, or 13? So do you have any idea like how we can find out the answer of this question? Like number of IPs in this subnet, total number of IPs, because I can see like 3 IPs already in use, but we're not interested in used or unused IP. We want to get the answer of total number of valid means usable IPs, means excluding 2, right? 2 combination need to be excluded, of course, first and the last. Any guesses?
Hold on.
How many?
Hold on. Just one minute.
Okay, yeah, sure. You can do it. I'm just taking a pause of 2 minutes so you can perform your computation. I'm not in hurry, so yes, you just take your time and perform computation. And if any confusion, the question.
I would say 14.
You'd say 14 means answer number C. Okay, let Vahe is also doing computation. Let him finish computation then.
I will say 6 because the remaining host bit is 4, and then 4 times 4 the power of 4 times 3. 4 and
2 raised to the power 4. Yes.
Yeah. So 2 raised to the power of 3, which is 8, and then minus 2, which is 6.
2 to the power 8 minus 2. Okay. So, and that's why you calculated 6. But now see, like the number of bits is equal to 4 or 3. So first, like the mask is /28 here, right? So what would be like host bits, 3 or 4? Yeah, Rashid, I think answered 14, right?
Yes.
Okay. So your understanding is, Rashid, why 14? If you say like 14, then why 14? Because Yahe is like saying 3 bits and 2 raised to the power 3 means 8 minus 2, that comes to 6. You mention here 14. So why 14? I mean,
it was 16 and then subtract the first and last bit. So that was 14.
Okay. Yes, correct. So yeah, like you did one calculation wrong here. So 2 raised to the power 3 is 8 minus 2, that comes 6. It's all good. But if you look at this, so the CIDR block given, like the CIDR notation, our network bits given here is 28. And mask means 32 bits. So 28, like from the question itself, it is very clear that network bits is equal to 28. So now the question is like host bits, how many host bits? So if you subtract 28 from 32, and why 32? Because IP address and subnet mask both are of 32 bits. So here the host bit is not 3, it is 4, right? Rest of the calculation is correct. So only like computing host bits should also be correct. Because if you somehow you have computed host bits 3, then from that calculation, yes, like 2 raised to the power 3 minus 2 and then 6. Okay. But basically host bits is equal to 4. 4 means 2 raised to the power 4 and minus 2. Rashid was correct. So 16 minus 2, and that comes to 14. So here the answer is C, 14. And similar type of questions are generally asked in your CCNA. certification exam. So if you are planning to give CCNA exam, so these type of questions are generally asked. Let me quickly jump to the next question. Yeah, I understood like where you have done
Yes.
now.
Yes.
Okay, good. All right, so let me go to the next question. In the diagram below, in order to have as efficient IP addressing as possible, which network should use a /29 mask? So here, like the clue is, there are different networks here, and in this small network, 30 hosts or 30 IPs required in network B. Here, 20 hosts, 14 hosts here, maybe 6 hosts, 2 IPs, 2 IPs, 2 IPs. So already is given in the question that you will be using mask /29, means 3 bits would be remaining for, of course, your host portion. So we don't want to get into that discussion like why 29 chosen or something, because the question here is something different. It's asking about the class ABC or D. Like D is however you understand. D is for the multicast. E is for the research. So basically, we have 3 classes: A, B, and C. So the question is like whether you would prefer subnetting class A address, or you would prefer subnetting class B address or class C address. Obviously, you will be doing subnetting like using, and after the computation, subnet mask would be like /29. So it's not asking about the complete computation, asking about which class you would prefer to do the subnetting. I mean, like whether you will take class A and do the subnetting, like so many subnets, like so that you can get /29, or you will pick a class B and then you will do the subnetting, or you will pick class C or class D. So you'll have to just answer this way: A, B, or C, D. So D is obviously ruled out because D is not for the unicast communication. You understand that, right? So now the question is like whether you would prefer doing subnetting of class A, B, or C to meet this, like to to meet the requirement like shown here, like above in the diagram. Like I can see like 6 hosts somewhere 14 or something. So it's not very tricky one, but and not very like something like which requires a lot of computation to be done. So in simple way, like you can answer this type of question that definitely I would prefer class C, because already class C is the smallest network, 254 usable IP. So better like to take class C and then doing further subnetting. Because if we are taking class A or class B, then very large network, and then definitely unnecessary a lot of subnet would be created. So we would not be interested in that. So not very tricky one. So let me jump to the next one. Probably this would be the best one. Okay, so it's asking VLSM stand for variable length subnet mask. Variable length subnet mask is something like in one subnet, let's say subnet mask is /27. In another subnet, maybe /28, maybe somewhere /30. And if you look at this example, so again here, I can just spike it there. Here also, let's say here like you want 60 computers. Here like you want to create a LAN network of 120 computers, and here only 2 IPs. So obviously it's not something like you will be using same subnet mask everywhere. I mean, like if you are using here /24, so maybe here like /26, maybe /27, 27, 28, something. So in different subnets, if the CIDR block or the value not same, right? Not same everywhere, then technically known as variable length subnet mask. There is another term, fixed length subnet mask. So if I'm using /24 subnet mask here, /24 here, /24 here, everywhere /24, or maybe everywhere /26 or 27, whatever mask I'm using, if the same mask I'm using everywhere in different network, here, in different networks. same mask, maybe 26, 26, 26, 26. So that is known as fixed length subnet mask or FLSM. And if I'm using here /27, maybe here /28, here /29, so it is known as VLSM, variable length subnet mask. So there are two terms like VLSM and FLSM. So would be of course important when we'll be doing routing. So in subnetting, not very important for now at least. So let me go to the main question here. So question is, which mask should you use on a point-to-point WAN links, wide area network links, in order to reduce the waste of IP addresses? So now the question is, what subnet mask you should use, right? WAN link, P2P link. So this is WAN or P2P link, R1 and R2. So now the question here is, IP address you are using here, any IP address, let's say you are using 192.168.10 dot or 192.168.50 dot, no problem. What mask you will use like here? Because if you are using, let's say, forget about the IP address, whatever IP you are using, no matter, class C or 10 or 20 or 30. If subnet mask you are using here /24 and here again /24, means two IPs from a class C major network. Major network means /24 means a network with 8 host bits, means 2 raised to the power 8 minus 2, 256 minus 2, 254 IPs. So what we have done, we have utilized only two IPs from a 254 big network. This way we are going to waste 252 IPs. So if my answer is like, I'm going to use /24 mask right here. If I'm using /24 mask, so basically I'm not justifying with this question, because the question is what mask you should use to minimize wastage of IPs. So obviously /24 is not the right answer, wouldn't be your right answer, right? /24 means what? A very big network. You are leaving behind 8 bits for the host. So that way host would be equal to 254. And we understand, like, if these two devices are connected P2P, so we need a very small network, maybe a network with only 2 valid IPs. That would be the most appropriate, because that way we wouldn't be wasting any IP address, right? But will that be possible? And if possible, then what would be the subnet mask? What value I should assign here? That's what the question is. So let me read again. Which mask should you use on point-to-point WAN links in order to reduce the waste of IP address? So again, I'm taking a pause of 2 minutes. Perform your computation. Try to answer me this question. What mask I should use? And I believe you now understand the concept of point-to-point WAN link. Means indirectly, question is a very smallest network. If possible, then a network or subnet with only 2 IPs. And if that is the case, so what would be the mask, like the value, cider block value, this number, right? Of course, and this number like cannot be, you cannot go beyond 32. You understand that 32 is the maximum. So I'm taking pause of 2 minutes. Do your computation and answer me like which option is correct.
I'll say D in my answer.
So your computation is /30, right?
Yeah. Because 30 minus 32 would be 2. The 2 to the power is 2 is 4 minus 2. So those are the two I will use.
Good. So Hassan answer is correct this time. He said like answer should be D/30 and absolutely right. And why? Because if you will take /30 means you have left 2 bits for the host. And if 2 bits for the host because total 32. So this way 2 raised to the power 2 minus 2 only 2 IPs. So this way even we have zeroed like wastage, no wastage of IP at all, because this way like even a small subnet would be created with only 2 IPs, right? So you can assign 2 IPs, one IP to this router WAN port, right? And another IP address from the same network to this one. And I will show you how this computation will be done, and quickly if I can show you that computation also, so that you can understand better way this one, the third question in fact. However, answer is correct, /30 is absolutely right. So if I take any network, let's say if I take class C network, so if you remember how we start doing subnetting. So let's say if I take this 192.168.1.0, so without doing subnetting, default subnet mask of this class C network is, if I have to write down in binary, so would be much more better. So 3.3.6.2.8, then again 3.3.6.2.8, 3.3.6.2.8, and then 3.3.6.2.8. So this portion is known as network bits. So without subnetting, network bits 24 in class C and host bits 8 without doing subnetting. We are doing subnetting in reverse order this time. So we are leaving only 2 bits for the host. We are leaving 2 bits for the host because we know that if we use 2 bits for the host, so total number of IPs would be equal to 2 only. If we leave or use 3 bits for the host, so 2 raised to the power 3 minus 2 IP would be 6 then. So intensely what we did, we left or we are leaving 2 bits for the host and rest will be borrowed for the subnet. So the first step completed. So borrowed bits that we have borrowed, however we really don't care. So borrowed bits is equal to 6 and host bits now 2, and 6 borrowed bits means total number of subnets will be equal to 2 raised to the power 6, whatever value comes, I believe 64. 64 what? Subnets. And how many hosts per subnet? So for that we subtract minus 2. So if we have like borrowed 6 bits from the host, means 6 bits is what? Subnet bit now. And 2 host bits. Means we have now divided this network, class C network, into 64 subnets, right? 64 subnet. Even though requirement was not number of subnets, in question requirement was IPs, right, in each subnet. So yes, subnetting can be done in either way, right? If your objective is to divide a network into n number of subnets, one criteria, and another criteria could be number of hosts per subnet, right? There are two different ways of doing computation. So this time around, we are doing computation in different, like keeping different requirement in mind, right? Requirement is what? Number of IPs. So we don't care like how many subnets are going to be created. My requirement was like number of IPs. But yes, if like we have left 2 bits for the host, so definitely required or not required, but network would get logically divided into 64 subnets, even though we don't care about subnets. And then what we do next, we write down this value in decimal to find out the decimal value. So for decimal computation, what we do if you remember, then just convert subnet bits into ones, right? Only 2 zeros. So now in decimal representation, this would be 255, 255, 255, and then here its decimal is 252, or insider block I can say 30. Count number of ones definitely would be 30. 8 ones, 8, 8, 34, and 6 here. 6, I'm sorry, one is missing here. 6. So 24 plus 6, 30/30. We got the answer. But anyway, if we have to do computation further, so the next step is finding out block size, the magic number, right? And for that, whatever value comes here, this number need to be subtracted from 256. So what is block size? 4. So how I will be writing down then the network address subnet as this and like everything like this. 192.168.1.0, and then the block size is 4. See here. Then the third subnet, 8. Then the next subnet. I'm not going to write down all the subnet, you understand, 12. And what will be the IP address range? Range of IP address. 1.1 to 1.2, only 2 IPs. .3 broadcast address. Here, 192.168.1.526, only 2 IPs, right? And then .7 is the broadcast address. So that's the way how further computation would be done. 2 IPs, a very small network with only 2 IPs. And believe me, service providers, right, generally use the same mask /30, I mean, in decimal 252, in like WAN connections, WAN port, your internet connection, right? So if you have internet connection coming from service provider, so your Wi-Fi WAN port would definitely be using /30 mask, right? That's very common most scenario. Just to make, because one end would get terminated at service provider and router, and one end at your home or office. Only 2 IPs. So mostly WAN ports, P2P links means /30 mask. Right? Makes sense. I believe you understand how this computation would be done. So it's something like subnetting is done keeping in mind the number of IPs, not like considering number of subnets. Right? So we do subnetting in both the ways. Right? If your objective, your requirement is like dividing a network into n number of subnets, is one way of doing subnetting. That there is a one network, divide into 4 subnet, divide into 8 subnet is one requirement. Another requirement is what? Divide into any number of subnets. I don't care. What I care is like each subnet should have 2 valid IPs, 6 valid IPs, 10 valid IPs, 30 valid IPs, right? Sometimes we never get the exact number, right? So what we try to do, we try to reach to the nearby number, right? So if I have been asked to devise this network into very small network, my requirement is that each small network should have 10 IPs. So now I will take like, if I take only 1 bit for the host, then technically 0 host. If I leave 2 host bits, then 2 IPs. If I take 3, so 6. If I take 4, then 14. Where is 10? Either I can use 3 host bits or 4? But 3 means like only 6 hosts cannot be used. Nearby, but higher side, not towards the lower side, right? So 10 IPs means you cannot go with this network of 6 hosts only. No, even like you can go with a network of 14 hosts. Definitely 4 IPs would be wasted, don't mind, but you cannot go with this. So if this is the question that divide a network into any number of subnets. I don't care about the number of subnets, any number of subnets. What I care about number of hosts, number of IPs per subnet. So my requirement is 10 IPs. So what I will do, I will leave 4 bits forward host. So what would become the CIDR block then? Any answer? What I should write here, slash. If like computation is leaving 4 bits for the host. Forget about the class ABC. In general, like what would be the CIDR block then? What CIDR block I should write?
28.
28. Yes, correct. Because total 32 and number that we use here define network are including subnet bits, like as a whole network bits, we can say. Network bits can be further segregated into network and host bits. But yes, whatever number we write down here is equal to network or subnet bits, right? And host bits, of course, after adding host bits, the result should be 32, exactly 32. So if 4 bits are reserved, then definitely like 28 host bits. So that's the way how computation is done. Now let me go back to this question again. So yes, like this way answer is definitely D, means slash 30. Okay, so now here is question number 4. Host A is configured with an incorrect default gateway. Host A is configured with an incorrect default gateway. And you now understand gateway, role of gateway. And all other computers and the router are known to be configured correctly. So question here is, understand the question. There is a switch, for example, host computers means like computers connected this way. Router here. This is a symbol of router, right? Router. So question here is, there is one host A. Host A is configured with incorrect default gateway. So gateway is not properly configured on one host. All other computers and the router are known to be configured correctly. So they all have proper configuration. One of the host A, has improper gateway configuration. Only the gateway is not correct, right? Gateway, not IP and mask, gateway. Now, tell me which of the following statement is true out of 4 options. Which one is correct? A, B, C, or D. Again, I'm taking pause of a minute. Read question again and answer me. Yes.
I'm saying A.
So you are saying option number A. Okay. What about others? What do you other guys think? So answer this and then we'll try to further investigate. So A is, however, host A cannot communicate with the router if gateway is not configured or incorrectly configured. Harshan, yeah, hai? Any answer?
B, host A can communicate with other hosts in the same subnet.
Host A can communicate with other hosts in the same subnet. You are saying option number B, right? Okay. And yeah, I think you didn't answer me. So what is your take like? A, B, or like you have different option to choose from? Because the third option is host A can communicate with host in other subnets, And D is host A can communicate with no other systems. And option number A is like host A cannot communicate with the router. Host A can communicate with other hosts in the subnet. So what is your take? A, B, C, D?
A is, I think.
Okay,
Correct.
so you also want to go with A. So 2:1. So two like votes given to A and the one is like B. So now let me explain the question.
Yeah.
Let's say in this scenario, router address is, let us assume 10.0.0.1. This machine IP is 10.0.0.2. This computer IP is 10.0.0.3, 10.0.0.4, 10.0.0.5, 10.0.0.6. So obviously these computers should have gateway, default gateway configured as 10.0.0.1, because whatever IP we assign to gateway is also very much like one of your host device, nothing else. Gateway is also is one of the host device. So generally what we do, we configure 10.0.0.1 as the gateway IP address, right? On all host devices. On all host devices, gateway address should be 10.0.0.1. The question here is, host A is configured with incorrect gateway. Let's say I've configured host A with the gateway 10.0.0.40. Fine. Wrong gateway address, right? Gateway address is not correct. And other host devices, they have proper gateway address configured. All right, so they all have proper gateway address configured except one host. Now, host A cannot communicate with the router is incorrect. Why it is incorrect? Because if host A, the first machine here, wants to communicate with 10.0.0.1, again, gateway is not required because this computer IP is 10.0.0.6 and router IP is 10.0.0.1. They both are in the same network. Not required. Gateway address is not required. Even there is gateway, there is improper gateway, no problem. Because router has proper IP address configured. Host A doesn't have proper gateway. So definitely router IP address will be reachable. But host A can communicate with other hosts in the subnet, yes. Because this host A will communicate with router also, right? Other computers also. But the problem would be if the like IP address, let's say this is host A IP address is 10.0.0.6. Now, if you want to ping 172.16.0.1, so for this, if the computer host A doesn't have proper gateway configured, if I assume gateway address as 10.0.0.1, and this machine has not the correct gateway address. Let's say accidentally by mistake, I configured this IP as gateway. This is wrong. Gateway should have been 10.0.0.1. So now if I initiate connection to IP of different network, yes, it is a problem. Because now router A will search, will look for the gateway, which 40, but as there is no 40 IP here. So gateway wouldn't be reachable at that time. But when this computer will try to communicate with different network, but if directly I try to ping 10.0.0.1, then yes, it is reachable. So it was a bit tricky, in fact, right? So through the router, I cannot route traffic to different network through the router. So if the destination IP is different IP, not from the same network range, then yes, it will be a problem. Gateway cannot be reached then. But if directly I try to ping gateway address, if I directly try to communicate with the router, so yes, router is also very much treated as one of the host device of the network, so it would be reachable then. So question was a bit tricky, but yes, answer is correct, and answer would be B. Host A can communicate with other host in the same subnet. But host A cannot communicate. No, this is not right, because host A can communicate with the router. Host A can communicate with host in other subnet. No, because in other subnet we cannot reach without a gateway or proper gateway configuration. Host A can communicate with no other system. Again, this is wrong, because in the LAN network, gateway not needed, not required. No matter whether there is gateway, improper gateway, blank, no matter. Single network, no problem. They all will communicate. There are some more questions we'll try to attempt tomorrow. Would be a very lengthy session otherwise. So total, I think there are 10 questions here. So we'll try to solve all the 10 questions. So it's a quick recap of your subnetting and a little bit tricky. So even wherever I would feel like there is requirement of some other concepts, like as already I have discussed about gateway concept. So I will bring those kind of discussions also in between. Otherwise, straightforward, we'll try to attempt other questions, right? And then once like attempted, then I will share this PDF, because at the bottom there are correct answers written, right? So I don't want to show you the correct answers. So, but once done, then I will share 10 questions, these 10 questions also with you. So, and once we have moved from subnetting to the next part and the next topic after subnetting, probably if I will be able to spare out time tomorrow, then I will introduce this device, router device also tomorrow. And step by step, I will first start with the initial and the basic configuration, and then configuring this whole routing, because the objective would be communicating different networks, not only two networks. In future, we'll be adding more networks, right? 5, 6, 7 networks. And then we would configure routers so that different networks, maybe in different locations, communicate with each other. So the topic is known as IP connectivity. So far we have discussed only within the network, and within the network you have seen like no configuration is required in general, just physical connectivity and then IP address assignment. That's it. Even gateway is not required, right? But yes, later on we will discuss like some configuration in LAN also, because if your LAN network is growing up in size, in the LAN network you have 5,000 computers, a big enterprise network, right? A big call center, sitting a lot of like agents, and you are the IT guy like to maintain this network. So obviously, network segmentation would be required then. A lot of network segmentation. We cannot design a single flat network, a network of 5,000 computers in the same building. No, network would be really very, very slow. Users would would not have very good experience. In fact, they would think that they're working over the internet, even though like in the same network, in the same building. So we'll understand how to do network segmentation, because the concept is known as virtual LAN or VLAN. And then if multiple switches are connected, so how to ensure loop-free network, highly redundant. So we will understand that in switching section. That is known as switching section. Switching part are Ethernet networking. And this portion is your routing and IP connectivity and the WAN part. So I will start first like from this router, and then I will back to this LAN network again, right? About switches, VLAN, spanning tree protocol, a lot of like internal network related issues. So because I will follow my way, because I don't want to introduce like difficult part once subnetting, since very much it was required like in routing and everywhere. So no option without understanding subnet mask, subnetting, even we cannot move from here no way. That is why even there is another important topic that need to be discussed in the beginning, but my way is something different. I don't teach in the beginning. The topic is OSI model, like layers of network, like there are total 7 layers. Very, very important topics. But generally, I teach this topic later on after just giving some basic foundation level knowledge, right? So once you understand like routers, firewalls, switches, TCP/IP, a bit of TCP/IP, already we have finished some other protocols. Then I will teach you OSI model. So it's also like this topic generally like is covered in the beginning, in fact, but in my classes I teach OSI model later on in the later part of your training, not in the initial like days, early days. No, I don't teach OSI model because again it's a bit confusing and very theoretical part. So I teach OSI once like you'd become comfortable with routing and switching both. So my objective would be first starting with routing, and then I will be covering your switching part, and then security, right? So different sections are there: routing, switching, security. So I'll move step by step. No rush, in fact, I'm not in hurry. So I will end up today's session here. So if we conclude today class, so we understood gateway concept, what is gateway, and we also attempted 2 or 3 important questions, tricky one, uh, as a quick recap of your subnetting concept. Tomorrow again, I will start with this PDF, right? We'll attempt like remaining questions first. This way your subnetting knowledge would be, like revised, in fact, properly. And then I will start this router, initial configuration, right? Interfaces, and then the routing part thereafter. Okay. And probably from tomorrow, we would be starting lab session also altogether. I mean, like theory plus lab. And then you would also need then this Cisco packet tester installed on your laptop or desktop, because in order to do the practice of commands like CLI, and that's the best way, in fact, because even if I write down all the commands, I just share any resource with you, like here is the PDF, just read all the commands. No, that won't be very useful, right? I know, like I have approximately 20 years of like classroom teaching experience, so I understand very well that just sharing like PDF or document files not always helpful. So better like I will show you practically all the commands, and then just run those commands in your lab environment. And that's the best way. Like once you run the commands like 2 or 3 times, automatically those commands will get remembered very easily then, right? So no need to like read any PDF or any book for that. That's the best way of doing lab practice. Run the commands, do mistakes, correct that, then again do. And that's the best way. Like, so you won't commit any mistake in the future. So lab related topics means like the only way is doing lab at your own. Like, so you'll have to keep your hand dirty. In fact, you'll have to do all the labs and all that at your own. And once, yes, definitely, I will show you how to set up, how to create lab topology, how to implement lab, what should be objective, how to start with. Yes, definitely. Once, like I will show you, I will practically implement like in the lab in virtualized environment, and then you can repeat same lab at your own in your own virtualized environment. I mean, like using the same simulator packet tracer. And this one is the good one, in fact, for CCNA. So learning CCNA on this packet tracer is always good. At advanced level, we have GNS3, we have EVNG, and some other simulators. But at CCNA level, not required. So no need to get like those simulators installed on your laptop or desktop, at least for CCNA. All right, so I'm just ending up today's session here. So if any question, any doubts, so still you can ask me. Otherwise, like you can even ask tomorrow also, no problem. And tomorrow again, I will start from the same like submitting questions, answers. And then I will share this PDF again so that if you want to go through all the questions again, then you can attempt like doing all those questions again at your own. But let me finish tomorrow first, and then I will share, because at the bottom, in fact, all the answers are given. In fact, only the answers like option A, B, C, D. So I don't want to reveal like those answers. So because the system would be more interactive if we don't know the answer. So that's the best way. All right. So any question, guys? Good so far? Understood a bit of subnetting? I mean, like, should I end up the session, today's session? Because if
Yes.
no question, then I will end up here.
Yeah, I think we're good.
Look good, I guess. Yeah.
Okay, Hassan, Rasid. Yeah, good. I think he is on mute. No problem. All right. So even in case if any question is there, like if any question is like comes up in your mind, so even you can ask tomorrow, no problem. So I'm always open to take your queries, to answer your questions. So anytime you can ask me. You even in between also you can interrupt me. So if I'm teaching something and if anything like pops up in your mind, like then you can interrupt me at that time. So I'm not so rigid, like if I'm in flow, I'm teaching something, so you cannot interrupt me. Anytime you can unmute your mic, you can ask me, you can put your question in chat window. So either way, like you can raise your hand. So I'm not like that kind of trainer that you cannot disturb me. Like I mean, like if I'm in flow, I'm teaching something, so you cannot interrupt me. Anytime you can interrupt me. I don't mind being interrupted multiple times, no issues. All right, so see you tomorrow then, same time. So in this week,
Yeah.
we would follow same schedule, right? Monday, Tuesday, and Wednesday.
Got it. Thank you.
Okay. Okay. All right.